Hey, it's Alex from Inside Gadgets, and today we're going to be looking at how to build a flash cart. So let's look at the cartridge pins. We've got 5 volts, clock, WR for write, RD for read, CS for chip select. We've got the address lines, A0 to A15, the data lines, D0 to D7. We've got the audio pin, the reset pin, and ground. Let's look at how the Game Boy interacts with the game cartridge. So we've got our clock up here, and we've got the write, the read, chip select, the address lines, and the data lines. So by default, these 3 control signals are high, and when the Game Boy wants to access, for example, a write to the cartridge, it just pulses it low. And when it wants to do a read, it will pulse this one low. And both of these happen when the clock is low. Chip select is also known as the memory request. So if it wanted to do a write to the memory, it would be pulsing this at the same time as the write. And if it wanted to do a read, it would pulse this at the same time as a read. The address lines are always output, so it will set the address just before the read or the write to the address that it wants. The data lines are an output or an input depending on if it's doing a write, which is an output, and if it's doing a read, then it's an input. So here we have the connections for a typical 5-volt flash chip. We've got the address lines, we've got the data lines, the chip enable, we'll go back to that one later, the output enable, which is also known as RD, we've got the write enable, also known as WR, VCC, that's 5 volts, then that's VSS, which is ground, and no connect means just don't connect that. So let's say we wanted to build a 32 kilobyte flash cart. So we need to do 2 to the power of 15, which gives us 32 kilobytes. Since we start off at 0, we just need 15 bits, so that would be A14, that gives us our 15 bits. Now, since these are our address lines, all we need to do is connect these directly to the flash chip. So for A15 on the flash chip and to A16, we need to ground those. Otherwise, if you leave them floating, you'll get inconsistent reads or writes. For the data lines, we can just directly connect those. We can connect OE or read to the read of the Game Boy. The same thing goes for WR, that can be directly connected. We connect this one to 5 volts, connect this one to ground. Now chip enable is a little bit different on the flash cartridge. It's kind of like writing to the SRAM like you would here, but you have to do that all the time. So we have our chip enable and we have our read. So both of these, as before, like on the Game Boy, both of these need to go low in order to do a read or write. Now you can potentially just leave CE low and just pulse RD or WR whenever you need to, but then we'd have a problem with the Game Boy memory map. Let's have a look at that now. So here's the Game Boy memory map. Our cartridge would be 32K, so it would take 0 to 7 FFF, which is the hex for 32 kilobytes, and the Game Boy uses these addresses internally. If we were to have chip enable low permanently, if the Game Boy tried to read from the video RAM, our flash chip would respond instead of the video RAM. So what we need to do is wire up CE so the flash chip only responds to something below 7 FFF. So anything over 8000 in hex will set the A15 bit high. That means we could just simply wire up the A15 bit to the CE pin. So whenever we go over 8000, CE will go high, and whenever the Game Boy wants to access the ROM back, CE will go low because A15 will be low. And that's the basics of building a 32 kilobyte flash cart. For the next part, we'll look at how to write to the flash chip, how to extend it past 32 kilobytes, and then eventually how to add RAM. Thanks for watching.